Okay, if you would take out your note-taking guide to the page that looks like this. The lesson topic is applications of linear inequalities and systems of linear inequalities. So what we are doing is taking the last 2 days from in your book section 7.5 and 7.6, and we are putting them together for some application or word problems. So let's take a look at number 1. Suppose your budget allows you to spend no more than $24 for decorations for a party. That no more than is that inequality piece. Streamers cost $2 a roll, tablecloths cost $6 each. Use intercepts to graph the inequality that represent the situation. So first of all, we're going to let X equal the rolls of streamer, and Y equal the number of tablecloths. So then we would take the cost of the streamers, which was $2, and multiply by X, our unknown of rollers of streamers, and then tablecloths cost $6 plus 6Y. And I'm not just going to write equals 24 because I can spend no more than 24, which means that I can spend 24 or less. So this is the amount that I'm spending. I want that to be less than or equal to 24. Okay, so to find the intercepts, we are going to, as we noted before, we're going to graph this like it is the line equal to 24, and then we're going to shade to indicate where I can spend. So to find the y-intercept, I put 0 in for X. When I do that, I get 6Y equals 24. So I'm going to do that work over here. 2 times 0 goes away. 6 times Y equals 24. I divide by 6. So Y equals 4. To find the x-intercept, I put 0 in for Y. Once again, I'm going to solve the equation. 2x plus 6 times 0, which cancels that out, equals 24. Dividing both by 2, I get that that equals 12. Remember, that's the x-coordinate when y is 0. So I'm going to graph those things. I'm going to put label my axes. So this is the rolls of streamer, and this is the tablecloth. And I'm going to go ahead and put my y-intercept on the y-axis, my x-intercept on the x-axis. From before, this boundary line is going to be solid. Remember, we've learned before that this is a solid boundary, meaning it includes the line, and this, when they would be just less than or greater than, is a dotted line or dashed line. So I'm going to connect those points, use a ruler or straight edge, and then I'm going to pick a test point to shade, and I like to pick 0, 0. So recall again, I pick a test point to tell me if it makes the inequality true, then I am on the correct side of the line. So my test point is 0, 0, which is down here, and I'm going to check if it makes the inequality true. Is 2 times 0 plus 6 times 0 less than or equal to 24? 0 is less than or equal to 24. So that means that the region that is going to be my solution is on this side, the 0, 0 side of the line, so I'm going to shade down here. Now keep in mind though, some textbooks will only put solid dots on the grid marks because we aren't going to have half of a roll of streamer and half of a tablecloth or anything like that. As long as you realize that, that's okay to just leave this as a line and shade below that. Okay, let's take a look at the second example. A grandmother wants to spend at least $40, but no more than $60 on school clothes for her grandson. What this tells us is we're going to have two inequalities that we're going to be graphing here. T-shirts sell for $10 and pants sell for $20. How many t-shirts and pants could she buy? So, first of all, I'm going to let X be the number of t-shirts, and Y is going to represent the number of pairs of pants that the grandmother can buy. For my first inequality, I am going to write 10X plus 20Y, and she wants to spend at least $40. That means 40 or more. So I'm going to write a greater than or equal to 40. For my second inequality, I am going to use the same thing. The pants and shirts still cost the same amount, 10 for t-shirts, 20 for pants, but this time no more than 60, so 60 or below. Okay, so now we're going to be graphing two lines. Let's go ahead and find the X and Y intercepts. At this point, most of us, I think, can do this in our heads. If I put 0 in for X, I'm going to cover that up, and I got 20Y equals 40, and I divided, I would get Y equals 2. And if I put 0 in for the Y to find the X, this would cancel out. I'm just showing my work over here. 10X plus 20 times 0, which is 0, equals 40. I divide by 10. I get the X-intercept to be 4. So I'm going to go ahead and graph that. Remember, this is my number of t-shirts on my X-axis, and the pairs of pants is on the Y-axis. I'm going to plot my X and Y intercept. Oops, not that. Okay. Alright, so that would be my first line. My second line, I'm going to do in a different color. I'm going to go ahead and do the same thing. I'm going to put 0 in for the X. So 10 times 0 cancels. 20Y equals 60 this time. The Y-intercept is 3. Put 0 in for the Y coordinate, which cancels the 20 times Y out, and I'm left with 10X equals 60. The X-intercept is 6. So I'm going to go ahead and graph that set of ordered pairs. Once again, my lines are going to be solid for this. Okay. So you may or may not notice, and because the X and the Y's are the same, that these lines appear to be parallel, okay? And they are, and they're going to have the same slope. So in this line, If I would pick the test point 0, 0, I can see that 0 plus 0 is less than or equal to 60. What that tells me is I'm going to be shading below this line. So I'm going to do that real lightly here. If I would put the test point in up here, 0 plus 0 is not greater than or equal to 40, which means I'm not going to shade on this side of the green line. I'm going to shade on the other side, which would be above the line. So the solution is going to be where they have in common. In other words, where does the shading overlap for those lines? We talked about this yesterday. So I am going to fill in darker now, or if you have a highlighter, you could highlight it, I suppose, what they have in common. That area is the solution. So if I wanted to pick two possible solutions to the problem, I would pick somewhere in this yellow shaded region. For instance, I could pick this point right here. That would be one t-shirt, 2 pairs of pants. That would be one solution. Or I could pick maybe this one. That would be 3 t-shirts, 1 pair of pants. However, those are just 2 possible solutions. Anything that is in this area that I shaded or highlighted where the shadings overlap would be a solution to that system. So that is a little bit of an introduction. This would just be one inequality, an application. This would be what we would call a system of inequalities, because we had 2 inequalities and we were finding the region where they had in common.